In this chapter review, I'm going to be going back and talking about each individual lesson, kind of just a quick overview. So the first thing that I'm going to be talking about is a horizontal and vertical translation. So as I'm sure you remember, if we have f of x plus c, this is how we can find a vertical translation. So if it is greater than 0, this means that we have a shift up. If it is less than 0, we have a shift down. In terms of horizontal translations, that is when we have a d inside of our function.
Hello.
Now this will seem a little bit backwards because of the minus sign right here. So remember that if something says x minus 3 inside of this bracket, your d is a positive 3. The negative has to be part of the equation. So technically it is still, if d is greater than 0, this is a shift right. And if d is less than 0, this is a shift left. But I'm just going to leave a little note here for you to remember that it might look the opposite of what you think. So x minus 3 and x plus 3 would be the shift left. The next thing that we talked about are reflections. So when we have a function with a negative in front of it, we know that this negative represents a reflection in the x-axis. So I'm just going to draw a quick little example. I'm going to use a quadratic because we did already have a full chapter on that. So this is x squared. And if I wanted to do a reflection in the x-axis, I could do this, and it would be a negative x squared. The next reflection that we talk about was inside of the bracket with the x. Now this is still a reflection, however it is in the y-axis. So if I were to draw a function, I'm just going to use the square root of x. The reflection would look like this. So it would look like the square root of negative x. And of course, it is possible to have both reflections. So if we wanted to have a reflection in the x and the y-axis, I'm getting ahead of myself a little bit here, it would look like negative f of negative x. The last thing that we talked about is a stretch of functions. So we talked about two stretches or compressions, a vertical stretch and compression and a horizontal stretch and compression. So first up is going to be the vertical stretch and compression. This is one that you have been used to seeing. You saw them a lot with quadratics. So if we have an a out front of our function, this is the vertical stretch or compression. Now for this one, if a is greater than 1, that means that we have a stretch by a factor of a. And if a is between 0 and 1, that means that we have a compression by a factor of a. Now remember, if a is negative, that doesn't really tell you anything other than there's a reflection. The a itself should only be the number. So even if it says a negative 2 in front of something, the a is only 2. The negative is dealt with later when we're dealing about the reflections. A horizontal stretch or compression is taken care of by a k inside of the bracket here with the x. Now this one is backwards compared to our a. So for this one, if k is greater than 1, this tells us that we have a compression by a factor of 1 over k. So for example, if it's 2 in there, that means that it's being compressed by a factor of 1 over 2, or 1/2. If k is between 0 and 1, I don't know what I just wrote there. This tells us that we have a stretch by a factor of 1 over k. So for example, if it was a 1/2, we would have a stretch by a factor of 1 over 1/2, which is actually just 2. I thought it would be a nice idea to go through a couple of examples just to talk about what kind of translations we're dealing with. Our first example is e of x is equal to 3x squared minus 5. So the first thing that I wanted to mention is that this does have a base function of y equals x squared. So if I asked you to graph this, the first thing that you would do is graph the x squared. When I'm looking at this, the first thing that I see when I read this from left to right is a 3. This tells me that my a is 3, which means that we have a vertical stretch by a factor of 3. Now I'm just going to draw a quick little sketch down here just to kind of explain what's going on. So my base function, yours would have some actual points on it, but I just wanted, again, just a quick little sketch. Here's my base function, x squared. Now I'm going to draw in this red, okay, this 3. So this entire function is going to be vertically stretched by a factor of 3. So basically I'm taking all of the y values on all of these key points and I'm multiplying them by 3. The next thing that I see when I'm looking at this is this minus 5. This minus 5 is my c value. So this tells me that there is a shift down 5 units. So now this red function is being shifted down 5. And this is my final function, e of x. I figured that I would do an example like this. Maybe I'll make it a little bit harder. I figured that I would do an example like this just because, as I mentioned before, it does confuse a lot of people. So before I can continue, I do need to factor this bracket out. So when I do that, I'm going to be getting 5x plus 4 squared plus 1. Now, as I'm going from left to right, a lot of people would want to say that this is an a value. This is not an a value, and the reason I know that is because in my original equation, the 5 is included in this first set of brackets, which is all being squared. This tells me that this 5 is a k. If my k is 5, I know that this is a horizontal compression by a factor of 1 over 5. Now, the next thing that I'm seeing is this plus 4. This is inside of the bracket again with my x, so this is my d value. Now, since it says plus 4, it does mean that my d is negative 4, and this is a shift left 5 units. The last thing that I'm seeing is this plus 1. That is my c, and it is a shift up 1 unit. Now before I can graph this, I do need to determine what my base function is. So right away, again, I do see a base function of x squared, so a parabola. The first thing that I'm seeing is a horizontal compression by a factor of 1/5. That means that I'm taking all of the x values in all of these key points and I'm multiplying them by 1/5. So everything will get a whole lot skinnier. Notice this looks very similar to a vertical stretch. That is because we can rewrite this as a vertical stretch, and I will show you how on the next slide. The next thing that we did is a shift left 5 units and a shift up 1. I'm okay with doing D and C in one graph change just because moving something left and up or right and down is very easy. So I'm going to be taking this blue graph, shifting it left 5 units and up 1. So here's where my new graph will start, and this is what my h of x will look like in the end. On the previous slide, we quickly just sketched what this graph would look like after the transformations have been applied. We know that this is a horizontal compression by a factor of 1/5. I did mention that it looked the exact same as a vertical stretch, and we could rewrite this as a vertical stretch. This would not be a vertical stretch by a factor of 5. Unfortunately, that's not how it works. Because this 5 is inside of this bracket, which is being squared, we do need to square it before we can take it out. So if I wanted to, I could rewrite my function to look like this, which would then say that we have an a of 25, so a vertical stretch by a factor of 25, and the remaining transformations would be the exact same.